Alright, welcome back. In this video we're going to talk about row echelon forms. Just basic row echelon form and also reduced row echelon form, which is a way of describing the way a matrix has basically been row reduced completely so that it more or less tells you the solution set of your system. So for example, if this is an augmented matrix that represents the system of equations, usually draw it with a line where the equal sign would go. This represents 1 times x plus 0y equals 4. And the second equation is just y equals 5, so it just tells you the solution. Now you notice the second one here actually just tells you the same system of equations. It's just written in with the rows 1 and 2 swapped. But this one is actually not what we call row echelon form, and it's nice to just have a consistent definition so that everybody's kind of trying to draw their matrices in the same shape as they're solving their system of equations. Also, by the way, I should mention here that all of this doesn't just apply to a matrix that is the augmented matrix of a system. Sometimes your matrix might represent an augmented matrix like this, or it might actually just represent the coefficients on the other side. So maybe this represents like 0, x1, 1, x2, and then 5, x3. And then there's actually like that's equal to something like, I don't know, something else we don't know about on the other side. That's another way we sometimes look at a matrix, is just look at the coefficients part. And sometimes we also just multiply a matrix by another matrix and do algebra that way. So matrices can represent all kinds of different things. And the nice thing about linear algebra is that row echelon forms are useful for all of these different things we might do with matrices later on. So let's get down to business. The leading entry in a row is the leftmost non-zero entry in that row. So you can just look at each row of your matrix. In this case, the leftmost non-zero entry is this 1. The leftmost entry in the second row is a 0, but 0 is not non-zero, but 1 is non-zero. So there's that. Here we've got leading entries here and here. Here we have them here and here. Let's just label all of the leftmost non-zero entries in each row. And if it's all zeros, there's just no leading entry there, like we have with these last two. Okay, so now a matrix is in row echelon form if all of the 0 rows are at the bottom. So a 0 row is like what we have here. They need to be written at the bottom of the matrix. So we've got that. Those are the only 0 rows here. So that sounds good. Each leading entry is to the right of the leading entry above it. And this is really the critical thing here. So we look at where are the leading entries, and are they to the right of the leading entries above it. And if it's in the first row, then there's no leading entry above it, so this just doesn't apply to that, so it still counts. So in this case, there's nothing above this first leading entry. The one below here, this is to the right of the leading entry above it. So if you go from here, the next leading entry is over that way. So that counts. Here though, if you look at this leading entry, the leading entry to the right, the leading entry above it is to the right, it's not to the left. So this is not echelon form. This first one is row echelon form. And let's look at this next one here. So the first one is always okay. The leading entry here is not to the right, it's directly below, so that does not count as to the right. And here, let's see, we have a leading entry here, a leading entry here. That looks good. That is to the right of the leading entry above it. Same thing here. And let's look at this one here. We have the leading entries highlighted. This one is to the right. The 4 is to the right of the 2. Yeah, that counts. Actually, maybe I should make a rightward arrow. That would make more sense. We're saying to the right of. Okay, and this 1 is also to the right of the one above it. So it looks like that. And this one actually has the same shape. So this is row echelon form. Okay, so that's what it means to be in row echelon form. And you notice some of these aren't exactly done. So some of the ones that are in row echelon form, like this one, for example, it would be nice if instead of having a 2x1 here, we had like a 1 times x1. And now, if it is a row echelon matrix, we're going to specifically call the leading entry a pivot. So a pivot is just a leading entry in a row echelon matrix. And by the way, what the word echelon comes from is it's a French word that means staircase. So you can see that going to the right as you go down to get a pivot leaves you with something shaped like a staircase. But you wouldn't want a staircase that's shaped like this or something because you'd fall and hurt yourself. Anyways, now a row echelon matrix isn't completely done yet. There's still more to be done if you really want to solve the equation to get it into what's called reduced echelon form, like this one is. That's where the pivots are 1, and everything above each pivot is 0. So here is that definition written down. Let's take a look at this and check which of these matrices are in reduced row echelon form. First of all, it has to be in echelon form in the first place. Reduced row echelon form doesn't make sense if it's not already in row echelon form. So with this first one, yes, each of the pivots is 1, and each of the entries above each pivot is 0. The entries below each pivot are already going to be 0 just because of the fact that it's in row echelon form. If you had a non-zero entry below a pivot, then that would probably be a leading entry below, directly below another leading entry. So anyways, so it has to be in reduced row echelon form, it also has to be zeros above each pivot. Anyway, so these are already out of the running because they're not in row echelon form already. This one has, it's in row echelon form, but it's not reduced echelon form because the pivots are not 1. Here, this is in row echelon form, and it's also reduced row echelon form. So I'm going to call it RREF here. And with this one, this has entries above this pivot 1 that are non-zero. And this 4 needs to be not a 4, it needs to be a 1. So this is not our REF. This one is in reduced row echelon form because it is in row echelon form, and everything above each of these pivots is a 0, and the pivots themselves are a 1. So next, let's look at an exercise for you to try. All right, here is your exercise to do to make sure you can tell what echelon form looks like and what reduced row echelon form looks like. So determine if each of these matrices is in row echelon form or not, and if so, if it's in reduced row echelon form. And I'll show you the answers in about 10 seconds. So let's pause it here. Here's the answers. So with the first one here, the problem is there's a leading entry directly below another leading entry. With the second one, it's not in row echelon form because there's a row of all zeros, which is supposed to be at the bottom. So this one right here, it is in row echelon form because each leading entry is to the right of the leading entry above it. However, it's not reduced row echelon form because of the 4. This one, however, is reduced row echelon form. This one, number 5 over here, is actually the reduced row echelon version of number 1. You could do a scaling operation on row 2 to multiply all of row 2 by 1/2, and then do a replacement operation to get rid of the 3 below that. You would do -3 times that new row 2 plus row 3 to make a new row 3, and you'll get this. So that is reduced echelon form. Number 6 here might be a little controversial, and you might be thinking, well, it doesn't have any leading entries anywhere, and you're right, it doesn't have any leading entries anywhere. But you can say anything you want about the leading entries because when there are none. That's kind of a convention in math, is that if there are no leading entries here, any statement you make about them is kind of automatically true, and we call that vacuously true. So yeah, this is a weird example that is actually row echelon form and is reduced row echelon form.